Hey guys, welcome to Section 1, Chapter 5 of the Geometry program. And this is going to be a real quick chapter. We're just going to do a handful of sections in this, and then we're going to move on. But the few sections that we're going to do I think are important, but I don't think that they're difficult. So, this one is entitled Midsegments of Triangles. And the triangle midsegment theorem states that if a segment joins the midpoints of two sides of a triangle, then the segment is parallel to the third side and is half its length. All right, remember geometry is all about the theorems. So we are going to apply this theorem in this section. But this is essentially what it looks like. So if you have K and J as midpoints, it means that the segment KJ is parallel to the segment AC. So KJ is parallel to AC. And it means that KJ is half of AC. It's half the value. So if AC is 80 and KJ is half of that, then I know that this value has to be 40. Okay? This is basically where we're going to do the whole section. So hang on tight. All right, here's our first example. We want to be able to identify pairs of parallel segments, right? Maybe it seems obvious. I hope that it does. If it's not, I'm just going to step you through it. Okay, so if we're looking at segment AB here, then what is the segment that's going to be parallel to it? Well, it's going to go through the opposite midpoints. So if it doesn't seem obvious to you, it's going through the opposite midpoints. So YZ is going to be the segment that's parallel to AB. All right, similarly, if you have segment BC here, then the segment going through opposite midpoints is the segment XZ. And then finally, you're going to have this tiny segment here, and he is going to be parallel to AC. AC is parallel to XY. Oops, let me get a line over there. All right, so just look for the opposite midpoints and you should be okay. Now, what happens if you start from the inside and work out? All right, so what if you have XY here? Well, look for the long segment that it doesn't intersect. So in this case, it's AC. And then what if I have YZ? So look for the long segment it doesn't intersect, and it has to be AB. Get some dashes over there. And then finally we have XZ, and it's going to be parallel to BC. All right, so half your assignment is literally just identifying parallel segments. So that's not too bad. All right, now let's go ahead and apply this idea that the segment through the midpoints is going to be half the third side. All right, so when you have something kind of simple like this, hopefully you'll be able to say, all right, so this segment is 1/2 the long segment, right? So X has to be 50. Because the long segment is twice the short segment, or the short segment is half the long. You can go either way. I'm going to show you how to do that. All right, so that's really obvious, but what if we have something that looks like this? Something that's less obvious, where we need to solve for X. So there's two ways that you can set this up. You decide which way in your mind seems the most obvious. So you can either say this short segment is half the big segment, so 4x is going to equal half the big segment, or you can say that the big segment is 2 times the short segment. So the first guy is half the long segment, or the long segment is 2 times the short segment. Either way, we're going to get the right answer. So 4x is going to equal 16 and x equals 4. Or 32 is going to equal 8x and x equals 4. So I'm not sure in your mind which is going to be easier to set up, but either one works. So the short segment is half the long, or the long is twice the short. Okay, so in this guy, now we have the short segment as 7, the long segment as 6x minus 4. So I'm guessing, like, overwhelmingly you guys don't like fractions, like in this first instance here. So I'm guessing that we're going to start maybe with the way that we solved it in number 2, where the long segment, 6x minus 4, is equal to 2 times the short segment, because everybody likes to avoid fractions when they can. All right, so this would be 6x minus 4 is equal to 14. Then you add 4, and you're going to get 6x is equal to 18, and x is equal to 3. Okay? All right, let's do another one. What about if you have like a big old complicated situation like this? All right, they tell us x, y, and z are the midpoints here in your picture. They give us some information. They give us xz, they give us ac, they give us ab, and then we need to find these 3 missing segments. So to start with bc, we need to see which line he's parallel to. So BC is this outer segment here, and he is going to be parallel to XZ. And XZ is the short side, he's 25. BC is 2 times that. So 2 times 25 would equal 50. Okay? Now what if we take XY? So XY is this segment, and he's parallel to this guy. AC is 90, and I know XY is 1/2 of 90, which is 45. Finally, you have YZ. This is our last segment here. Of course, he is going to be parallel to AB. AB is 60, and I know that YZ is 1/2 of that long side. And 1/2 of that long side is going to be 30. All right, I just have one more example for you, and you should be good to go here. All right, take note, I haven't really said this explicitly, if it doesn't say that these points on the segments are midpoints, what we look for are the congruent signs. So when we have a segment that's split into 2 congruent segments, then I know the points are midpoints, and therefore we can apply this theorem. So that is the case in this picture. It doesn't explicitly say the points are midpoints, but I know that they are because each of the outer triangle segments here and here and here are split into congruent segments, right? Notice the 2 dashes here. All right, so they don't give us any solid starting point, but what I know is that this segment Y is going to be 1/2 its parallel side, right? Which is 1/2 2x plus 3. And I know that this x here is 1/2 its parallel side, which is 5x minus 12. So at least in this case, this first case, we have 2 variables. We can't solve that. But in the second case, we have 1 variable that we could solve. Now, you guys should be comfortable at this point being able to solve a problem with 1/2. But keep in mind, if for some reason you're like kind of freaking out about it, then you can say, all right, 2x, or twice the inner side, is also equal to 5x minus 12. Right? So the inner side is twice the outer side. Okay, but either way, you would do the same thing solving up here. You would multiply both sides by 2 to get rid of that 1/2 if you didn't want to distribute it. And then I would subtract 2x from both sides and add 12, and x would be 4. All right, you guys, that's it for this lesson. Go ahead and finish up your notes, read through the examples, and begin your assignment.